to solve systems with linear programming is by graphing. So graphing will be coming back into your lives today. So, do you remember what the purpose of linear programming is? Why do people do linear programming? No? Okay. Well, people physically don't do linear programming anymore because computers do linear programming for us. But the purpose of linear programming is to identify max and minimums. So linear programming is a technique that identifies the minimum and maximum value of some quantity. Okay, so linear programming is a technique that identifies the minimum and the maximum value of some quantity. In the real world, usually we only care about maximum. So if you're talking about profits, you want to maximize your profits. In the case of finding the minimum value, maybe you want to minimize the amount of waste or minimize the amount of product that you need to use to make the most maximum profit. Okay. So when we're talking about linear programming, I'm going to be using these vocab words, so you need to make sure you know what I'm talking about when I say it. So when I say, what's the objective function? The objective function is the model of the quantity that you, yes?
After the switch am I going back? I just missed the last few words.
Can you wait until we just get through everything? Okay. The model of the quantity that you want to make as large or small as possible. So there's going to be a lot going on with our linear program. We're going to have to set up an objective function. We're going to have to set up some constraints. We're going to have to find our feasible region and all this fun stuff. Okay, so your objective function is what it is that you are trying to make as large or small as possible. So usually profit or costs. You want to make your cost as small as possible. You want to make your profits as large as possible. So then we're going to have what's called the constraints. And your constraints are the limits on the variables in the objective function. Okay, so whenever you're doing a linear programming problem, you need to show the constraints, you need to show the objective function, and the last thing you're going to have to be able to show is what's called the feasible region. So your feasible region contains all the points that satisfy all the constraints. Okay, so this feasible region is going to come from our graph. Now, here's the thing. You're going to be doing graphing. Now, your homework, I provide graphs for you, so that makes life nice for you. For your notes, you're not going to have a graph. But because we're dealing with real life things, you're probably only dealing with positive numbers. So when you make your graphs, you're only going to be focusing on the first quadrant. Okay, so you don't need to make your origin in the center. Your origin will be down in the lower left-hand corner. Okay, so here is what a linear programming problem could look like. Can you just wait till the end? I'll let you get there and look at all you want to. All right, so what I would like you to do in your notes, all you have to do is write the objective function down. So this part right here. And don't worry about all this other stuff. So we're finding the values of x and y that maximize and minimize p for the objective function p equals 3x plus 2y. I would jot down in your notes these constraints. So my constraints on the function is the inequality y is greater than or equal to 3/2 x minus 3. Y is less than or equal to negative x plus 7. And most likely you're always going to have x is greater than or equal to 0, y is greater than or equal to 0. That 0 may change depending on the situation, but most likely we're not going to have negative numbers, which is what this is telling me, that I can't end up with negative numbers. Okay, so do you guys remember how to graph linear inequalities and find the intersection of linear inequalities? Hopefully. All right, so make yourself a quick first quadrant grid. You're going to have to go all the way up to 7 on your y-axis, because my y-intercept is 7. All right, so what I need to do is graph my constraints. So let's start with the first one. It tells me that I have a y-intercept of negative 3. Well, that's not going to be anywhere in there. So now I have to think of something else. If I wanted to find my x-intercept, how would you find your x-intercept of this equation?
Can you just graph the negative 3 and then draw the line across?
You could, as long as you make sure you get it exactly there. But let's just get our thinking caps on. Finding x-intercepts mean you make what 0? The y 0, right? Find your x-intercept, make your y 0. So if I make my y 0 and I add that 3 over, I get 3 equals 3/2 x. Well, I'm just ignoring that for now. I just want to get my x-intercept. Multiplied by the reciprocal of 3/2, which is 2/3. So what's my x-intercept going to be? 2. Good. So that means I can put a dot at 2 on my x-axis. From there, my slope tells me to do what? Up 3 over 2. So go up 1, 2, 3 over 2. Would I have gotten there if I started at negative 3? Yes, I would have. Keep going as far as we can. So let's do a few more. Up 3 over 2. Do one more up 3 over 2. Solid or dotted line? Try again. Solid. Good. Okay. We'll do our shading after I get everything graphed. All right, so let's do the next one. Here my y-intercept is at 7. So put a dot at 7 on your y-axis. 1, 2, 3, 4, 5, 6, 7. And my slope tells me to do what? Down 1, over 1. Okay. So points that I really care about, make sure you really can find where that point of intersection is. What is my point of intersection? That's at 1, 2, 3, 4, 3. So I'm going to label that a 4, 3. Okay. Now I got to think about where my feasible region is going to be. My first line, I need to be greater than, so that would be above my line, right? My second line needs to be less than, so it'd be below the line. Where would the intersection of those two shadings be? Yeah, so here, I'll show you quickly. Don't put this in your notes. So there's the blue. Let's get a different color here. Here's my red. So the intersection of the two is this feasible region right here. So shade in the feasible region, which is all of this area right here. So now that means any coordinate that falls within my feasible region follows these constraints, because they're all positive, so I'm good there. So that means I can pick any point in here, plug it into my objective function, and get a value for p. But what I care about is finding the values that maximize and minimize that. Now think about this. Out of all of these points that are inside this shaded region, which point do you think would minimize, get the smallest value for p?
4,3.
Try again. 0, 0, right? Isn't 0, 0 within this feasible region? Yes. So, what you're looking for, if this is your whole feasible region, you want to identify the vertices of that polygon. So this vertice is at 0, 0. This vertice is at 2, 0. We found our point of intersection at 4, 3. This top vertice is at 0, 7. So out of these 4 points, 0, 0 is going to be the minimum.
So for all of these, you're trying to find the lowest.
Well, it depends. It'll say either maximize or minimize. In this case, 0, 0 gets me a p of 0. When I plug in 2, 0 into my objective function, what do we get? 6. When I plug in 4, 3 into my objective function, we will get 12 plus 6, so 18. Is everybody okay with me doing this in my head? 4 times 3 is 12. 3 times 2 is 6, 18. 0, 7 gets me an objective function value of 14. Okay? So, 0, 0 gives me my minimum value. Which one gives me my maximum? 4, 3. And it may not always be the intersection point. Sometimes it's either this top or the bottom, either the y or the x-intercept that maximizes it, so you really should check all of your vertices. If it's asking for a maximum, it's unnecessary to check 0, 0, because you know that that's not going to be the case. Okay, Scott?
So basically for them, you just add the x and y's together and see if that put it back in the function.
Right, so well, you're putting it into the functions.
Alright.
I don't know, you're not adding the x and y's together. Like add, up here adding?
Yeah.
Yeah.
Alright.
Is that a hand, Nevin, or are you just, okay. All right, so now let's actually do a full word problem having to figure out for ourselves. So here in this problem, the constraints were given, the objective function was given. That's easy. The first 4 problems of your homework are just like this. And then it'll say, find the value that maximizes. If that was the case, then my answer would be 4, 3, with my profit of 18. Or p of 18. If it asked for the one that minimizes, then I would say 0, 0 with p of 0. Okay. All right, so now let's go ahead and set it up all on our own. So, suppose you're selling cases of mixed nuts. If I were you, I would just copy this box right here. So that's where all of our information is going to come from. So we're selling cases of mixed nuts and roasted peanuts. Mixed nuts, we get 12 cans per case. We're personally paying $24 per case. And then we're going to go and sell each can for $3.50. Which means we get an $18 profit per case. Roasted peanuts. There's 20 packages per case. We're paying $15 per case from the supplier. And then we're going to go and sell each package for $1.50, which means we're going to get a $15 profit per case. Okay, so now reading up here, it says you can order no more than 500 cans and packages total together, and we can spend no more than $600. So how can you maximize your profit? How much is the maximum profit going to be? All right, so let's figure out what my constraints are going to be. I can order no more than 500. So that means 500 is my maximum value. So I'm going to have a 500 with a less than or equal sign. If I let x equal number of cases of mixed nuts and y equal number of roasted peanuts, what would my expression look like on the left-hand side? Kyle?
Wouldn't it be $30 profit per case?
I don't know. Can you pause for that?
Okay.
We'll think about that when we get to the objective function. Okay? So if these two together can be no more than 500, what's that going to look like over here? Just a simple x plus y? So x plus y needs to be less than or equal to 500. Okay? Now, well, actually, hold on. That's not true. 'Cause this would represent number of cases. I need number of cans and packages. So what should I have in front of these? How many cans do we have with the one case? 12. And we have 20. Thanks. Sorry. So 12x plus 20y is less than or equal to 500. Now let's do the money line. We can spend no more than $600. Well, we're paying $24 per case. So 24x plus $15 per case for my peanuts. So that cannot exceed $600. Sorry, I know I'm getting low here. And we always need to attach, my x needs to be greater than or equal to 0, my y needs to be greater than or equal to 0 in this case, meaning I can't end up with negative number of cases.
I thought X and Y represented the cans and packages.
I'm doing number of cases. So x represents the number of cases of mixed nuts. Okay. So now let's quickly talk about this profit, make sure these are correct. So if you pay $24 per case and you sell at $3.50 per can, where's my calculator? Did you get 18? 350 times 12 minus 24 is 18, so that one's right. And if we do, we're selling at 150, so 150 times 20 minus 15. Yeah, those are right. $15 per case. The profits are right.
Because you subtract the amount you paid initially.
Right. Okay. All right, so these are my constraints right here. So now we need our objective function. So P is going to be equal to how much profit do I get per case for mixed nuts, 18x, plus how much do I get profit per case, 15y. And the reason why I need that x and y to be per case, Devin, is because right here it's telling me, like I want to know what my maximum profit is going to be. And my profit is telling me per case. That's why x and y needs to be number of cases. Okay?
Okay.
All right, so now the hard part, we've got to graph this. Let me quickly jot these over here to the side. So 12x plus 20y less than or equal to 500. 24x plus 15y less than or equal to 600. All right, make yourself a first quadrant grid. I'll do it with you here. So I want to try to make these numbers smaller. Can I divide something out of the first one to make my numbers smaller? If I think we can go bigger than 2. I can take out 4. So if I take out 4, that becomes 3x plus 5y is less than or equal to, what's 500 divided by 4? How many quarters do you need?
125.
125? Okay. What can I do to this second one to make it smaller?
Divide out 3.
Divide out 3. So 8x plus 5y is less than or equal to 200. Okay. All right, so if we need to graph them, what would you do to graph? Would you do x and y intercepts? Would you find it, put it in slope-intercept form? What would you guys do? Yeah, that would work. I'm going to do, you could do that. I'm going to do just x and y intercepts. What's my x-intercept going to be? Not as nice, huh? 40.
Something not nice.
So 4. You guys are all sitting there with calculators. Come on. 4, 0, 5, 1, 41 and something. So maybe we should just put it.
1/3.
So maybe we should just put it in the slope-intercept form. So 5y is less than or equal to negative 3x plus 125. Y is equal to less than or equal to negative 3/5 x plus, what is that going to get us? 5. You guys are making me think too hard here. 50, 25?
Yeah.
Okay, so we need a y-intercept of 25. So let's jump by 5s. Well, that might be.
Negative 3/5, that's right.
Yeah.
It's hard to read from here.
So 1, 2, 3, 4, 5. Means I'm going down. So 1, 2, 3, 4, 5, 6, 7, 8. My slope is negative 3/5. So down 3 over 5. 5.
Sorry.
I jump by 5s. 5, 10, 15, 20, 25. Go down another 3. 1, 2, 3 over 1, 2, 3, 4, 5. All right. Did I go down 3? I didn't go down 3, did I? 1, 2, 3 over 5. 1, 2, 3. This is why your life will be easier with the graphs provided for you. 1, 2, 3, 4, 5. All right. So let's make our line. There we go. The second one, we get 5y is less than or equal to negative 8x plus 200. Y is less than or equal to negative 8/5 x plus 40. So I need a y-intercept of 40. So I need to jump up. So 30, 35, 40. I'm going down 8 over 5. So down 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. That's nice because that gets me directly to an x-intercept. All right, so now since I'm graphing this by hand, it's kind of hard to tell what that point at intersection is. But we can get the rest of it. So my feasible region is going to be in here. My vertices are at 0, 0. This is 1, 2, 3, 4, 5, 0. My y-intercept is up there at 0, 25. So now we got to find this point of intersection. Okay, well now I got some options. How do I find the intersection of these equations? What was this? 8x plus 5y equals 200. Subtract, subtract, subtract. So negative 5x is equal to negative 75. So x is at 25. So when x is 25, what's my y going to be? So 75 plus 5y equals 125. 5y is equal to 75, right? 75 minus 125.
No, 75 plus
50.
75, 150.
So 50. So y is 10? No.
Sorry, I thought equal signs is negative.
Oh, you guys are making me think too hard here. So 75 plus 25 is 100, plus another 25 is 50, right? So that's right?
Yes, I thought
Okay.
the 50 was negative because it's equal sign.
Yeah.
All over here.
So 25, 10 is my other vertice. So what was our profit function again? P equals 18x plus 15y? Huh?
I'm trying to figure out the graphic, just the points in general. Like, how did you go down? You went down 5, and then is the bottom by 1?
By fives.
The bottom is
Oh, so this isn't 5, 0. Thanks. This is 5, 10, 15, 20, 25.
Okay.
Thanks. So now let's figure out our p-values for each of those. So you guys are going to make me walk back here and get my calculator. 25 times 15, or my 18 for the 25, 10. So 25 times 18. Here I get a p of 450. Now I'm going to do the point of intersection. 18 times 25 plus 15 times 10 gets me a p of 600. Going up here, I get a P of 375. So which one maximizes my profit? The 2510. So I need to sell 25 cases of, what was that, my mixed nuts? And 10 cases of peanuts will maximize my profit. If I can buy no more than 500 and spend no more than 600. Yes.
I'm still confused on this graphic. I don't know why I'm stuck on it, but I'm getting different lines than what you have.
Well, my graphs are probably off. I mean, it's by hand.
No, I know, no,
So
I mean,
1,
I'm
2,
like
3,
way
4,
off from where
5.
you are.
And my slope is what? 3 down 1, 2, 3 over 1, 2, 3, 4, 5 puts me here. Down 1, 2, 3 over 1, 2, 3, 4, 5 is going to put me somewhere down here. So that's where that line comes from. And then up here, we're starting at 7, going down 8. So 1, 2, 3, 4, 5, 6, 7. Did I start at? Yeah, because that would be 8 over 1, 2, 3, 4, 5.
I was individually counting it by the number itself and by how many times you go down.
Oh, well, if I do 40 over 25, that's the same as negative 8 over 5s, because I have my units the same. Okay? All right. Linear programming. You think you got it? Yes, maybe, no, kind of, possibly. All right, so let me